In this video, we're going to talk about 4.3 Objective 4, where we compute and interpret measures of variation. The celebrities with the top 8 net worths and millions of dollars in a certain country in a recent year are shown in the table. Find the range and standard deviation of these data. If you consider all celebrities rather than just this group, would you expect their measures of variation in net worth to be larger or smaller or the same? So let's take a look here at this list. Let's clear our data, our previous problems, and let's put in the list here: 5,500, 3,600, 3,000, 2,000, 1,100, 1,000, 1,000, and 850. Now let's go ahead and calculate our statistics on that list. And let's find our range and our standard deviation. Our standard deviation to the nearest tenth is 1665.5. And the range is going to be max minus min is 5,500 minus 850. 5,500 minus 850 is 4,650. If you considered all celebrities rather than just this group, the measures of variation in net worth would be larger, because you'd have people who would make significantly less than this group that is all in the top 8. Ayurveda is a traditional medical system commonly used in India. Listed are the lead concentrations in micrograms per gram measured in different Ayurveda medications manufactured in the United States. Find the range and standard deviation of these data. Given that lead is considered a poison, when it enters your bloodstream, what does the variation tell you about the safety of these traditional medications? So 2.9, 6.6, 5.4, 6.1, 20.7, 7.4, 11.7, 20.8, 11.4, 17.4. So let's find the range and the standard deviation. And standard deviation to the nearest hundredth is 6.54. And range is 20.8 minus 2.9. 20.8 minus 2.9 is 17.9. And the large variation suggests that you should be careful using these medications, especially with these high lead values that are possible, like there and there and there and there. About half of your samples had what appears to be high lead concentrations, so we would be careful with that. The following are body temperatures in Fahrenheit in randomly selected normal healthy individuals. Find the range and standard deviation of these data. What do these results suggest about what we should consider to be normal body temperature? So 98.6, 98.7, 98.6, sorry, that was 0.3, 98.3, then 0.6, 98.5, 98.6, 98.4, 98.9, 98.4, 98.4, 98.1, and stat calc one variable statistics and our standard deviation is 0.22. And our range is going to be 98.9 minus 98.4 is 0.5. While not all individuals have exactly the same normal body temperature, the results suggest that normal healthy individuals have very similar body temperatures. And one more question here about BAC, which stands for blood alcohol content of drivers who were involved in fatal crashes, and then given jail sentences, find the range and standard deviation. So 0.26, 0.18, 0.18, 0.16, 0.13, 0.23, 0.31, 0.23, 0.14, 0.16, 0.11, and 0.16. Stat calc one variable statistics, and we have a standard deviation of 0.059 and a range of 0.31 minus 0.11 is 0.20. While some drunk drivers who cause fatalities have very high BAC levels, others were fairly close to the legal intoxication limit of 0.08, and given the small sample size, this suggests that even lower BAC levels could potentially be dangerous. So that's it. We will come back next time and we will talk about 4.3 Objective 5. See you for the next video.